Okay, part A states, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show the computations that lead to your answer. So obviously in the chart here, we can see that we don't have a value for E of t at 6. 6 doesn't even exist. So in order to figure out this problem, we're going to need to be using the mean value theorem, which is f of b minus f of a over b minus a. In this case, f of b would be E of 7, and f of a would be E of 5 over, of course, 7 minus 5. Now for E of 7, simply look at your chart. E of 7 is 21. E of 5 is 13. 21 minus 13 over 2. 8 over 2 equals 4. So there's a total of 400 entries being sold. 400 entries being deposited at t equals 6. Part B. Use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of 1 over 8, interval of from 0 to 8, E of t dt. Using correct units, explain the meaning of 1 over 8 intervals from 0 to 8 E of t dt in terms of the number of entries. So we are given, we are told to use trapezoidal sum with 4 subintervals. These are our intervals. Now the formula for trapezoidal sum is 1/2 height times b1 plus b2. Now we're going to be using we need to calculate the value of this right here. So that's what we're going to be using from 1 over 8. And then, so we are going to be using the formula. We need to make sure to keep 1/8 outside because that's what's asking for. So here the height is going to be the distance between the subintervals. So for example, here we're going to have the first interval. The distance between 0 and 2 is 2, so that's our height. And then our b1 plus b2 is simply the values given in the chart for E of t. So b1 plus b2 would be 0 plus 4 over 2, of course, because of the 1/2. So the distance for there we want to do it through each subinterval. So the distance between 2 and 5 is 3. That would be our height. Our bases would be 4 and 13. So 4 plus 13 over 2 plus distance between 5 and 7 is 2. Our our bases would be 13 and 21 over 2. The last one, our distance would be 1, and then our bases would be 21 and 23. So 21 plus 23 over 2. Now this is a calculator problem, so simply when we plug this into the calculator, we are going to get 10.688. So that is the value of 1 over 8 interval from 0 to 8 E of t dt. Now in terms of the meaning of 1 over 8 interval from 0 to 8 E of t dt, that is the number of entries in hundreds between the interval 0 and 8. Correct. For part C, at 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976 hundredths of entries per hour for the interval from 8 to 12. According to the model, how many entries had not yet been processed by midnight t equals 12? So for this problem, we want to figure out obviously because it states how many entries have not been processed. So by looking at the chart, we know that the total amount of entries are 23. So we need to obviously to figure out the amount that have not been processed, we need to figure out the amounts that were processed and the total amount and subtract them. So we know our total amount is 23. Now for our total amount being processed, we need to find that, obviously, which would be area. So we are going to need to integrate P of t from 8 to 12, because that is what we are given. Those are our intervals. So P of t dt, and that should give us our entries that have not been processed yet. So 23 minus, and then this is a calculator problem. So just simply put that into a calculator, and P of t obviously being this function. So once we plug this into our calculator, we are going to figure out that this equals 16. So our number of entries is going to be 7. Yeah, it states that it is in hundreds, so it is 700 entries that have not yet been processed. On the interval a is less than or equal to t less than or equal to 12. Correct. For part D, it asks, according to the model from part C, at what time were the entries being processed most quickly? Justify your answer. So for this part, obviously saying process most quickly, so that has to do with rate. So we are going to need to be taking the derivative of P of t, which is 3t squared minus 60t plus 298t. Now since it's asking for the, 298. Now since it's asking for the most quickly, that has to do with max. So what we need to do is we're going to need to find our critical numbers. So by setting P of t equal to 0. Now this is a calculator problem. You could just simply plug it in to the calculator to figure out your zeros. And once you do, your zeros are going to be 9.183503 and t 10 point, you're going to get 2 zeros. This is the first one, that's going to be the second one. 10.816497. Now it's asking for the amount of entries that were being processed most quickly at what time. So what we need to do is then we need to and we're given an interval from 8 to 12. So what we're going to need to do is we need to set each and every single one of those values equal to t on P of t. So once we do that, our t of 8 is going to be 0. Our t of 9.183503 is going to be 5.088662. Our t of 10.816497 is going to be 2.911338, and the value of t of 12 is going to be 8. So from here, obviously we could see that the most entries were being sold at t of 12. So, not sold, excuse me, processed. t equals 12. And